Hi, in this tutorial we are going to solve a question related to nucleophilic acyl substitution reactions. Let's look at the question. Predict the products of the following reactions. Let's look at each reaction one by one. Let's here label this reaction as number 1. Then let's predict the product for this particular reaction. Number 1. Let's look at here. We have here an ester, and ester is reacting with Grignard reagent in the first step. Then we are reacting with acid, or we are acidifying the reaction medium. When you have a Grignard reagent, we have a carboanion nucleophile. For in this particular case, this is methyl magnesium bromide, so we will have a methyl anion. What's going to happen for this nucleophilic acyl substitution reaction? This part, the alcohol part, will be replaced by or substituted by the nucleophile, which is the carboanion here. So let's just write a simple reaction mechanism. Then we are going to lose this alcohol part, and what we are going to form? We are going to form a ketone. But we know that ketones react Grignard reagent one more time. So what we are going to end up? We are going to end up with an alcohol. Then the product will be this. Let's write here. So this carbonyl will be converted into an alcohol after we add the acid. Then we will have 2 methyl anion added to carbonyl carbon. So let's just draw this one and let's say this one. So this is going to be the product. So basically we are going to end up with a tertiary alcohol. Let's look at the second question. The second question, let's label as second here. We have here an acyl chloride, and here we have a nucleophile which is a primary amine, and we can think that primary amine is going to act as a nucleophile, and we are going to substitute the leaving group, which is chlorine, with the amine, and we will end up with an amide. So if we write the reaction mechanism, this will attack carbonyl carbon, the nucleophile, the amine, then chlorine will leave. So we will end up with an amide. Let's write here. This is N, and we have 2 more carbon. I will draw as skeletal structures. This is ethyl amine. Like we have 2 carbon here. Let's look at the third question. The third question, we have a carboxylic acid, we have an alcohol, we have here acid. So basically this is acid catalyzed esterification reaction or Fischer esterification reaction. So basically instead of a carboxylic acid, we will end up with ester. So we will just write the ester product for this particular compound. So this part is going to be the methyl. Okay, let's move to fourth question here. Let's look at here. We have an ester. Here we have DIBA, and then we are adding acid. So when we have DIBA is a mild reducing agent. It's a hydride source. Let's draw as a negatively charged hydride. So what's going to happen? Hydride is going to attack carbonyl carbon and will substitute this part, and we know that when we have DIBA, it's a mild reducing agent, so we can stop at aldehyde level in the reduction. So what's going to be the product here? Let's draw. It's going to be an aldehyde. So this will be hydrogen here. So basically this methoxy part will be removed. Then we will end up with this aldehyde. Let's look at the next question. This is again reduction of carboxylic acid derivatives, which we have here the reducing agent lithium aluminum hydride. Again we can think of this is a hydride, but don't forget lithium aluminum hydride is a powerful reducing agent, so we don't stop at aldehyde level, we go further. So let's look at here what's going to happen. So since this is an acyl chloride, so the chloride will be the leaving group. So the first reaction, we will lose chlorine and it will be aldehyde, but a second time another hydride will attack here, and we will have here inserting two hydrogens, two carbon hydrogen bonds, and this will be alcohol. So let's write the alcohol product. You can think of that 2 times reduction reaction will happen. I'm going to write this carbon here. We are going to have 2 hydrogen introduced, and this one will be an alcohol. So basically we get a primary alcohol. Let's look at the sixth question. Sixth question, we have a carboxylic acid and thionyl chloride. You remember thionyl chloride with alcohols. When we react alcohols with thionyl chloride, we introduce carbon chlorine bond. Again here, when you have a carboxylic acid, when you react with thionyl chloride, OH will be substituted by chlorine. So it's a nucleophilic acyl substitution reaction, but our nucleophile will be at the end a chlorine. So here we end up with an acyl chloride. And the last part, the last question, number 7, we have an acyl chloride, and we have here a carboxylate anion. Carboxylate anion will be our nucleophile. Chlorine will be our leaving group. So it's going to be an acyl substitution reaction. If we draw the mechanism, basically oxygen will act as a nucleophile and it's going to replace chlorine. If we write the reaction mechanism in a one single step, actually it will form a tetrahedral intermediate, then it will collapse back to forming a double bond, then chlorine will leave. But I'm going to show you with 2 arrows instead of 4 arrows. Okay, then let's write the product here. So instead of chlorine, I'm going to write this oxygen as our newly introduced group with the rest of the molecule, which actually here we synthesize an anhydride. So basically, if you have a carboxylate nucleophile, and if you have an acyl chloride, or sometimes this might be an ester or any carbonyl that has a leaving group, carboxylic acid derivative, so you can end up with an anhydride. So in summary, we have seen 7 particular nucleophilic acyl substitution reactions. Thank you so much for watching this tutorial.